Nalin, suddenly we lost, no?
Yeah, I have to end the meeting and then it worked.
I see.
I don't know, there's some technical issue.
Right.
Now come on.
Sir.
කට්ටිය නෑ නේද?
නෑ හිටියා මේ Nalin had to close the meeting. ඒකින්ද මේ there was some problem. Now I think they will come back.
Come there. එහෙමද? හරි.
There were more than 15. 15, 15. Because everywhere there is a power cut. So we can't expect a lot today, but what we can do is we can start recording.
Oh.
Yeah, and then then we can share it.
No, that's
because today's situation is bad, very bad.
We can't think of a better day, no.
Yes.
There won't be better days.
Yeah, there won't be better days soon.
Better days in near future.
Yeah.
So shall I start the presentation?
Yeah, 15 minutes already gone, ne?
Yeah.
We have to make an introduction.
Yes.
Shall I do it?
Yes, please.
Yes,
yes.
Today we are going to have the lecture number 2 on deep excavation best practices by Dr. Nalin De Silva. Dr. Nalin De Silva is serving as a senior lecturer attached to the Department of Civil Engineering, University of Moratuwa, since 2009. With over 18 years of experience as a geotechnical engineer, Dr. De Silva is largely involved in the analysis and design of deep excavation and foundation in Sri Lanka. This lecture will cover an introduction to the construction, selection of different deep excavation support system, different lateral support system, general guidelines on the analysis and design, planning and design of groundwater control systems, importance of monitoring during deep excavation, and contingency plans to minimize the risk of unexpected failure. Further, best practices for quality assurance and safety during construction of deep excavation will also be discussed today. This is a basic introduction of our resource person and as well as what he is going to present today. And now I want to make another announcement at the beginning of the Geoforum. Our next Geoforum will be conducted by Professor Saman Tilakasiri on application of or rather introduction of Eurocode that is called EC7. That is basically on geotechnical designs. He will make an introduction in our Geoforum schedule in the last week of Wednesday of last week in April. With that small note, I like to invite Dr. Nalin De Silva to make the presentation. I know it is a very great difficulties with the power cuts and so on. We have to conduct this Geoforum, but I think we are going to record this lecture and later also it can be used to our members. Thank you. Podium is for Dr. Nalin.
Thank you, Mr. Sabandu, for your introduction. In the last lecture, I have discussed about the general guidelines for geotechnical analysis and design, and I gave an introduction to the different systems available for deep excavation support. And today I'm going to discuss in brief about on how to control groundwater the methods available for monitoring and the importance of monitoring, and if the things are not happening as expected, what are the available contingency plans, and finally about the quality assurance aspects will also be discussed. So let me quickly move to
Nalin, can you go to the full screen?
yeah, sure.
PowerPoint,
This is just, okay, right, I'll go.
Yeah.
Okay, I hope you all
Thank you.
can see. Yeah, right. So I would like to discuss about the control of groundwater and the methods available for the selection of groundwater are presented in this figure. Depending on the permeability, the equivalent permeability of the aquifer to be dewatered, the different options available for different expected drawdowns. Actually, this figure is readily applicable for open type excavations because we don't expect a significant drawdown in supported or cut-off wall systems. We just want to there can be some small seepage plus the water inside the excavation have to be dewatered, but in open type excavation some drawdown is required to keep the excavation dry. So depending on the required amount of drawdown in meters and the permeability, we can think of different systems like such as deep wells, well points, sumps and so on. So in supported excavations, the open sumps are very widely used because we don't need to achieve a significant drawdown. We simply need to dewater the water inside the excavation. So and there are different the objectives of dewatering. Say for example, they are listed here. Stopping the surface water from entering into the excavation is one objective. Then we have to keep the excavation dry. That is the main objective of dewatering. So and this figure again gives the ranges of applicability of different methods as a particle size distribution analysis in a particle size distribution analysis plot. So depending on how it plots the particle size distribution and the falls into the different envelopes, we can think of selecting different methods for appropriate methods for dewatering. So one of the main design parameter is the coefficient of permeability clay. So typical values in the absence of field test data, most of the case we don't have field permeability test done for deep excavations. So in such case some typical values are given here. Porosity is important in the calculation of amount of the water to be dewatered inside the excavation, because below the water level you have some volume of water to be excavated. So porosity is a very useful parameter. Say for example in general a porosity of about 0.35 to 0.4 is used in the dewatering analysis. So that means if you consider the total volume below the groundwater table, about 35% to 40% of the total volume is water. So that amount has to be dewatered from the excavation. So the rate of the dewatering and the size of the pumps, also all the parameters can be calculated based on this calculation. So in addition to this the volume of water inside the excavation, there will be some seepage from the surrounding. The dewatering analysis can be carried out in two different two different ways. The predefined designs using analytical methods, graphical methods such as flow nets, they are widely used. Then there are numerical methods. Some typical examples are shown here. The numerical methods are actually there are spreadsheet based finite difference programs, and finite element packages are also available for dewatering analysis. Whatever you do, because this groundwater flow analysis is very much dependent on the coefficient of permeability of the aquifer, equivalent coefficient of permeability. So no matter how accurate or how advanced your analysis is, it has to be coupled with the observational approach, and the parameters have to be adjusted based on the observational records. That I have to emphasize. So I would like to quickly go through some available groundwater control systems. The sump pumping is the most widely used dewatering system for deep excavations. It's very effective and economical, and it can achieve a modest drawdown of about 2 meters maximum. So actually we don't need, if we are dewatering inside an excavation, we don't need a drawdown. So this is the most appropriate method in such case. Some typical arrangements for sump pumping shown here. So you can have some like a barrel, perforated barrel covered with some filter media, and inside you have the submersible pump, and can take water out from the submersible pump. In some cases, for large scale dewatering, concrete cylinders also can be used, as shown here, typically shown here. Then comes well points. Well points, we can achieve a drawdown of about 5-6 meters, and well points are widely used in open type excavations or trench excavations. They are not widely used in the deep excavations supported by retaining walls. And again, the most appropriate the envelope, particle size envelope for well point systems is shown here. So this can be used as a guide in selecting the well point system. So in the and there are very useful design monographs available. Although they are not very relevant for deep excavations, I would like to show you some useful design monographs. And for example, this one, the left hand one, it's applicable for uniform sands and gravels. The right hand one is for layered sands and gravels. So depending on the coarseness of the material, you can see fine sand, medium sand, and on the left hand side is the required drawdown in the dewatering analysis, the amount of drawdown required. So if you join this line with the type of soil, we can select the appropriate well point spacing, right? For fine sand, say for example 2.5 meter spacing in this particular case. So similar analogy can be used for the right hand figure as well. So these are very useful tools in the design of well point systems. The yield of a well point from a single well point having a length of 700 millimeters is given here. So it's just for information. And then comes deep wells. So deep wells are widely used to dewater from outside the deep excavations. So if there are no structures around, dewatering from outside can be considered, and deep wells can be used to achieve a significant amount of drawdowns and the depth of more than 10 meters. Drawdowns more than 10 meters can be achieved through deep wells, and the deep wells the depth of the deep well can vary from 10 to 35 meters, even deeper ones are also available. And a typical configuration of a deep well is shown here. So you have a large diameter borehole, and inside there is a perforated casing, and the annular spacing is covered with a filter media. The casing is usually covered with a geotextile, and inside you have the submersible pump. So some typical configurations are given here. Some typical pump, the discharge rates, the recommended minimum internal diameter of the casing, and the borehole diameters depending on the discharge rate are given here, and you can use this in selecting the appropriate the dimensions for the deep well. So I am not going to spend a lot of time on these. And then for the calculation of the yield from a deep well, this figure is quite useful. Depending on the permeability, x-axis is the equivalent permeability of the aquifer to be dewatered, and you can see different curves for different boreholes, the diameters, and you can get the yield, okay, in liters per second. So this is per a wetted length is it's like the slotted area of the casing. So some typical the design considerations for deep wells. Construction details are given here. It is recommended to have the slot sizes. The slot size is it's better to have the approximately equal to D10 of the filter media. Then about 20% of the casing has to be slotted. In general, geotextile is usually placed over the well screen, and when the deep well starts to operate, some ground subsidence can take place, and the filter media also can compact, and some depression, ground depression can occur. So due to this, it is generally recommended to place the filter media about 0.5 to 1 meter above the top of the slotted part of the deep well. Otherwise, what happens is the fine material will enter the deep through the casing, the slotted area, into the well, and it might affect the efficiency. So and it is also a good practice to have about a 300 millimeter filter pack at the base also. So the deep wells are susceptible to something called encrustation, that is due to the chemical precipitation or bacterial growth in the well screen. The efficiency might be affected in the long run if the deep wells keep on operating for more than 2-3 months. This can significantly affect the performance of the deep well. So we have to take appropriate measures to clean and redevelop the deep wells and recharge wells. And this system is not available in Sri Lanka as far as I know. I have inquired from different contractors, but they said they don't have this. This is called an ejector. In the ejector, the high pressure water jet is circulated, and when it goes through this nozzle, it creates a vacuum, and this vacuum sucks water into the pipe, the drain pipe. So this is useful, very useful in very low permeability soils such as silty sands or silts. For dewatering in such soils. So in addition to the ejectors, there are some other methods available like horizontal well pointing, pressure relief wells. Pressure relief wells are like sand drains. I'll show you some figures. Then comes collector wells. They are not used, very rarely used in deep excavation systems. Then the electro osmosis is also very rarely used in deep excavation. It is more like a ground improvement method than a dewatering method. But electro osmosis also can be used to dewater from very fine soils like clay type soils. So in some cases, dewatering systems, the given dewatering systems are used in combination as well. So pressure relief wells, as I told you, are like sand drains or gravel drains. Then I quickly go through this pressure relief wells. Sorry, this is a collector well. It's a large diameter. So this is actually not used as a dewatering system. It is this kind of systems are used to create like water supply wells. Okay, this is like a large diameter caisson and horizontal wells, right, are installed around the caisson. Then the electro osmosis, as I told you, it's not very rarely used as a dewatering method. It's more like a ground improvement technique. So there we have a cathode and an anode. You can see a cross section taken through the cathode and anode. There are metal strips. Copper is used and a power supply is given. So the water particles are attracted to the cathode and it can be pumped out using a perforated pipe. So the effects of dewatering are have to be carefully considered. Settlement resulting from the instability of excavation. So then there can be ground settlement due to loss of fines due to dewatering, and the ground settlement again can be induced by the increase in the effective stress due to dewatering. The drawdown of the water table, it causes the increase of the effective stress that can create settlements. And the other less important from the geotechnical point of view, I would say, the effects are depletion of groundwater sources, changes in the groundwater quality, environmental related issues. The ground settlement induced by the increase in the effective stress can be calculated using the equation using the coefficient of volume compressibility of the subsurface. Delta U is the effective stress increase or the pore water pressure change due to the drawdown of water table. H is the thickness of the compressible layer. So this can be used to approximate the ground settlement induced by the drawdown of the water table. So if this settlement is significant, we have to consider recharging of the groundwater table. So some recharging options are shown here. There are a large number of recharging options for deep, but for deep excavations, recharging wells and recharging pits are widely used. So I would like to only discuss about these two methods. So you can see on the left hand side a trench is used for groundwater recharging. On the left hand side a well is used. So these wells are more like the observation wells. So on the left hand side, if this the trench is not there, the groundwater table would be due to this is where pumping is taking place. The groundwater table would be something like this. So this drawdown is recovered up to some extent due to the presence of the recharge trench. This is the recharge well. So again, it is very similar to the observation well. You have a well screen, and this is the down pipe where you pump water into the discharge recharge well. Sometimes this is done under pressure, but we have to be very careful when recharging groundwater table under pressure or injecting water, because it might affect the stability of the excavation support system. So it increases the pore water pressure behind the retaining wall, and it can cause some distress on the retaining wall. So that we have to be very careful in that. Over recharging is not recommended at all. Okay. So as a general statement, it is much harder to recharge the water than dewater. So as a rule of thumb, it is said that to recharge back water into the aquifer from where it came, 2 or 3 recharge wells are needed for every abstraction well. So one dewatering well, if you want to recharge the same amount of water into ground, it is the rule of thumb is to have 2 recharge wells. So you can see that how difficult it is to recharge the groundwater table. So some application is shown here. This is one project in Kolpiti, and we have recommended this kind of recharge well near the important structures, because the structures are the places where we have to be worried about the differential settlement, additional settlement due to the drawdown of water table. So it is recommended to recharge the groundwater table close to important structures. So there are some issues related to groundwater recharge, and I'm not going to go into the detail. Mainly the aeration can cause gas binding, so we have to prevent the aeration of water. And again, if the water contains sediments or ions, it can significantly affect the efficiency of the recharging operation. So recharge wells are susceptible to clogging compared to the dewatering wells. So frequent cleaning of the recharge wells is required. So in some cases, once a month it's recommended to clean the recharge wells once a month using airlifting techniques. Better to remove the debris and the suspended solids at the bottom of the recharge wells. So you can see in the right hand side there's a figure. This figure explains about the frequency of cleaning of recharge wells. Not the only recharge wells, different dewatering systems, well point, submersible, ejector wells, and so on. Recharge wells are also there. When the iron concentration is high, you have to frequently clean. So that's the the recommendation. So if the iron concentration is less, so about at 1 month or in some cases 3 months interval is enough. Then I would like to move on to monitoring and contingency plans. So I extract this figure from the NBRO guidelines for foundation and the deep excavations. It can be freely downloaded from the NBRO website. So according to this, you can see that this is the yellow line demarcates the boundary of periphery of the excavation, and it is recommended. So prior to the excavation, we have to carry out the existing condition survey of the adjacent buildings. So it is recommended in the NBRO guidelines to survey the existing structures which are within 50 meters distance from the boundary of the proposed excavation. And special consideration shall be given to archaeologically important sites. Different methods available for monitoring. I'm not going to talk about the existing the condition survey. I'm going to talk about the monitoring of the deep excavation. Okay, so water level and the deformation and the strut forces are the and the ground heave are the parameters to be measured. So there are large number of monitoring instruments available, and you can see the among those methods, the methods the enclosed in the red color are the widely used methods in Sri Lanka. If I explain a few of them, like settlement of ground surface and the deformation of the wall, surveying methods are widely used. Then comes plumb lines are installed along the wall to measure the any inclination of the wall, and inclinometers are widely used in the deep excavations in Sri Lanka. Then subsurface settlement points are sometimes used. Piezometers and the probes are used for the water pressure measurement and the water level measurements in the observation wells. Crack gauges are used to measure the cracks of the existing structures and the structures surrounding the excavation. Then in some cases, some very deep excavation, very important ones, differential strain gauges and load cells are installed to measure the prop forces. So one of the biggest advantage of monitoring is that the monitoring records, other than the stability of the wall, monitoring records can be effectively used to validate and calibrate the numerical models, so finite element analysis results. So that is a very important aspect of monitoring during deep excavations. So some instrumentation are shown here. I will show you some larger schematic diagrams in the coming figures. So basically we have extensor meters, inclinometers, the strain gauges, load cells, and so on. So this is a typical ground settlement marker. You can see on the left hand side, it's a 16 millimeter bar driven to a depth of about 1 meter or more, and with covered with a concrete cap at the top. So this can be used to measure the ground settlement. And this is on the right hand side, a heave gauge. A typical heave gauge is shown, that is used to measure the ground heave, okay, during excavations. And this enlarged part is installed below the excavation surface. So this is the excavation level, final excavation level. So below 150 meters you have to install this the enlarged section, okay. And from the top you can take survey readings to measure the heave, ground heave. Then comes extensor meters. There are large varieties of extensor meter. A lot of patented the products are also available. In the simplest type of extensor meter, which is known as the fixed borehole type extensor meters, we measure the extension of a wire fixed to the bottom of the borehole. So that this gives, if there is a movement along the borehole, the wire will be extended and that extension is monitored. And these are some modern type of extensometers known as magnetic extensometers. So these are installed along the borehole. You can install them at different depths, and a sensor which is sensitive to the magnets of the magnetic extensometers. This is the probe. It is lowered. So when it detects the magnet, we can identify the location of the spider magnet. It's called spider magnet. You can see. By monitoring the location, we can get an idea about the movement of the ground. Right. Then some photos of the installation of load cells to measure the prop forces and strain gauges are shown here. You can see some vibrating wire type strain gauges are fixed to the steel eye section, and in this case the load cells are placed at the joint between two eye sections to directly measure the prop force. The strain gauges measure the strain, and by using the Hooke's law, the strain can be converted to the stress. The monitoring frequency is there are general guidelines, but the frequency of reading should be related to the construction activity. If the construction works are going very slowly, I mean, you don't have to take very frequent monitoring readings. So, and it has to be related to the rate at which the readings are changing. So if the readings are changing frequently, we have to take more readings to capture the behavior. Too many readings, in general, too many readings overload the processing and interpretation capacity, whereas too few may cause important events to be missed and prevent timely actions from being taken. So this is something very important. So it is generally required to carry out few sets of initial readings to establish a reliable frequency. Then it is always recommended to take readings after some disturbance, like a blast or heavy rain or an earthquake. So after some disturbance to the construction activity, it is always recommended to take monitoring readings immediately after the event. So as the construction activity moves away from the instrument location, or if the monitoring records seems to cease, we can think of increasing the monitoring frequency, reducing the monitoring frequency. You can take readings with a longer interval. So some general guidelines for the selecting the monitoring frequency are shown here. A benchmark where you take to compare with your readings. It is recommended to change the location, check the location of the benchmark, coordinates of the benchmark for every 3 months during a deep excavation. Then all the other monitoring records like settlements, inclinometer readings, the observation well readings, and so on, are recommended to take once a week in general, right? In general, as I told you, if some significant disturbance took place, like a heavy rain or earthquake, better to take readings immediately after the event. So in general, the instrumentations, inclinometers, so for example, should be installed at the location where the maximum wall deflection is expected, right? And the observation wells can be used for recharging as well. So we have to install them close to existing structures, because the effect of dewatering can be very significant on the existing structures. So as a general recommendation, install the inclinometers at the places where maximum deflection is expected. The observation wells, better to install close to existing structures. The inclinometers can be installed either through the wall or outside the wall and it should be fixed to it's recommended to fix to some the fixed point like the rock or a very hard strata. If hard strata is not available up to a significant depth, you have to go up to a depth where no lateral deformation is expected, and from there you have to terminate the inclinometer. If the inclinometers are installed outside the existing wall, it is generally recommended to maintain a distance less than 2 meters. You're measuring the wall deformation far away from the wall is it does not have a lot of use. So this is you can see a typical inclinometer casing and the inclinometer, and the working principle is very simple. It measures the inclination of this rod and inclination of this rod, and the length of the rod is fixed. If you know the inclination and the length, you can measure the lateral deformation using simple trigonometry. So that's the working principle, and this is how the inclinometer casing is installed through a diaphragm wall, for example. And when we insert the inclinometer in this direction, you can get the variation in the major movement, the variation of the deformation in the major direction, and by inserting the inclinometer in the other direction, perpendicular direction, we can get the movement in the longitudinal direction. So you can see some two typical records. In this direction we don't expect a lot of deformation because it's quite stiff in this direction, the wall. And isolated regular monitoring records are of not much use. So I have seen in many deep excavation projects, they take monitoring records just for the sake of taking the monitoring records, and isolated individual readings are available. Actually it's very difficult to interpret, so you have to plot the variation with time, right? And the trend has to be carefully monitored. The person who takes this reading have to be trained on identifying these trends, and immediately communicated to the relevant people for taking actions. So say for example, you can see this is typical lateral deformation survey measurement taken plotted against the time, and you can see in one location some abnormal behavior is recorded. So we have to carefully observe this, where this takes place, and see what is wrong here, and we have to take the appropriate remedial measures. This is again the settlement and with time. So you can see some trend, increasing trend. This has to be carefully observed. And this is the groundwater level variation with time. There can be seasonal variation also, so it's better to have some reference reading somewhere outside the excavation and compare the readings in your observation wells with the reference. So then we can clearly identify the seasonal variations and the water table variations due to drawdown. Then I would like to discuss about the maximum allowable wall deflection limits, and I took these two figures from the Singapore guidelines, Building and Construction Authority Singapore you can see that according to this guideline, the retained site, okay, is divided into 3 zones depending on the distance from the edge of the wall, the x, okay, x over h less than 1, that means this distance x is less than or equal to the excavation depth, right? Or and this zone 1 to 2, x over h ratio equals to 1 to 2, zone 2 and zone 3. So depend, if you have structures within zone 1, structures to be protected, important structures to be protected in zone 1, the maximum allowable deflection limit is 0.5% according to this guideline. Then if you have structures within zone 2, you don't have any structures in zone 1, but there are structures to be protected in zone 2 area, the guideline is bit relaxed, 0.7%, you can go up to 0.7% of the excavation depth h, okay, as the maximum allowable wall deflection. Then in zone 3, some values are given depending on different ground types. Ground type A is some good soils including residual soils, ground type B is soft soils, okay. Then the action limits, the control strategies. So for zone 1, the alert level is recommended as 70% of WSL is this the 0.5%, the allowable wall deflection limit, or it's known as work suspension level as well. Again, it's also called action level. So you have to take action, immediately stop the excavation, further excavation, and take appropriate the actions to prevent further the deformation. So 70% of the action level is taken as the alert level, right? And in zone 2 and 3, again some the alert levels, check level, alert level, and the work suspension levels are defined according to this. Then I would like to quickly go through the allowable settlements, building settlements. Depending on the amount of settlement, we can categorize them as negligible or severe, and the expected damage, structural damage. So some guidelines are given. Then about the angular distortion of structures, and 1:500 is the safe limit for buildings where cracking is not permissible. If the angular distortion is more than that, some cracks may appear on existing structures. And this is again a diagram, similar diagram. In the x-axis, the lateral the strain deformation is converted into a strain. That is, the strain means whatever the deflection divided by wall deflection divided by the excavation depth. And then this x-axis is the angular distortion. If you plot the angular distortion versus lateral strain, we can get an idea about the expected damage, structural damage. So I am not going to go explain this, because this is about the allowable settlement of the RC structures, individual footings, mat footings, and so on. So I'm not going to explain it in detail. Then I would like to discuss about the contingency plans. What should we do if the things are not happening as expected? So according to the NBR requirements, any contractor planning to carry out a deep excavation has to submit the contingency plans in their report. So these aspects have to be considered. Excessive lateral movement of the wall and ground settlement, right? If the lateral movement and the settlement is about to exceed the action level, what can we do? So we have to increase the number of lateral supports to reduce the unsupported length of the wall. In general, you have to increase the stiffness of the lateral support system. Then leaking through the wall, and this can be extremely dangerous, leaking through the wall, particularly in situations where the subsurface is sandy and water table is high, because you will see that particles will be lost in no time, and large ground depressions can occur on the retained side due to this. So immediate actions have to be taken. In the contingency plan, we have to immediately stop the further excavation, try to block the leak using the sandbags, straw, textile, fabric, okay, and try to manage or reduce the flow. Once the leak is stabilized, and somehow you have to stop the fines coming out from the hole. Once that is done, you may create some berm using sandbags, then inject grout columns behind the leaking section, and constructing a concrete skin wall also can be considered. If leaks are quite small, those leaks can be addressed from the outside, that means from the excavation side, right? Grouting can be carried out from the excavation side, but some serious ones we have to do the grouting from the behind. Then failure of dewatering system or insufficient drawdown, you have to have standby additional pumps, and the number of wells have to be increased. The piping, if piping or the excessive ground heave is observed, you have to stop dewatering and refill the excavation with water up to the level that adequately stabilizes the situation. Then once the situation is stabilized, we have to take permanent solutions like grouting, creating a grout plug at the bottom of the excavation. So these are very costly, expensive remedial measures. If excessive deformation is observed in adjacent properties, structural damage, we have no choice. We have to rectify the damages. Sometimes underpinning may be required. And if excessive seepage and groundwater lowering, we have to have a plan for groundwater recharge. Okay. So in general, if the drawdown seems to exceed 2 meters, better to think of recharging the groundwater table near existing structures. So this is some schematic diagram on how to address a leak through the wall. So I have already explained this, so I'm not going to spend time. And there can be issues in pulling out the sheet piles. In some cases, it creates a hole which is difficult to be grouted, and if there are important structures on the retained side, structures to be protected, we have to think of keeping them in place, right, permanently, sheet piles near the existing structures. Otherwise the pulling out of long sheet piles can create a lot of ground subsidence. Then there are some very expensive auxiliary methods for controlling wall and ground deformations, ground improvement in the deep excavation. So the creating a very stiff block type region or column type regions in the below the excavation level, or the wall type, the stiffening, okay, ground improvement also can be considered, but these are very expensive, and we have to do proper design for this kind of auxiliary methods. And some other techniques, auxiliary methods are also explained here. Creating counterfeit walls, right? The below the excavation level, we can think of creating counterfeit walls to reduce the wall deformation. Then cross walls, right? This is like a kind of soil strut, right? Reinforced, it can be reinforced or unreinforced, cement mixed or jet grouted cross walls can be constructed below the bottom of the excavations to stiffen and reduce the wall deflection. Underpinning has to be done in extreme case if there are important structures and if some excessive settlement is observed. We have to transfer the loads of the existing building foundations to either piles or some other support system. So that is called underpinning. Finally, I would like to discuss about the quality assurance good practices. Actually, it's better if this kind of practices can come from some regulatory body, but because I have not seen this kind of very detailed quality assurance practices in the deep excavations projects in Sri Lanka. So this is like a responsibility matrix for deep excavations. You can see different activities, items, and the R means responsible person, A is the authorized person, and this can be authorized. C is the chief engineer, P is the project engineer, and so on, the people. So you can see the persons involved in the project, and their responsibilities are well defined in this kind of metrics. The risk analysis. So different types of risks during deep excavation, and the risk levels has been analyzed and risk control measures have been defined. So the people who are involved in this kind of deep excavation have to be trained on the risks and the severity of the risk and the risk control measures. So some safety measures are shown here. I am not going to to explain this in detail. One important thing is we have to stack the excavated soil away from the edge of the excavation to prevent collapse of soil, and it creates a lot of other issues. It creates a surcharge on the excavation site. 1 meter of soil, loose soil, the surcharge can be about 15 to 20 kilopascals. So if you have say about 3 meter heap of soil, it creates a surcharge of about 45-50 kilopascals. So if the wall excavation support system is not designed to sustain such loads, can have a lot of problems. And if it rains, the excavated soil absorbs water and the weight goes up, and the problems can be severe. Then some safety checklists for deep excavations. This is a very general safety checklist. How to see whether these are in place, and signature of the engineer has to be taken before the start of the work on each day. And more detailed excavation checklist is shown here, and you can see that the activities are categorized into, say, general inspection of job site, and there are different checks to be done. Then utilities, someone has to look at the utilities, whether they are protected, supported, removed, and so on. Then means of access and egress, wet conditions, hazardous atmosphere, so different checks to be made. Then comes the support system. If I spend some time here, then the materials and equipment for support system are based on soil analysis, trench depth, excavated loads. Yes, someone has to check this. they are in good condition and so on. So a lot of checks to be done on the support system, and this is about this is an environmental checklist. When dewatering is taking place, it can cause a lot of environmental issues. So this is about discarding the dewatering the water. So some checklist is given here. And I forgot to tell that in recharging the groundwater table, you have to take clean water. If we are using the water from the excavation, it has to be clean prior to recharge, to using recharge. Otherwise, the recharge wells can clog very easily. So that's all. My presentation, and thank you very much for listening.
Thank you, Dr. Nalin. It is a very, very informative presentation, and a lot of important things have been focused and mentioned, and it is the time for discussion. I invite the participant to raise their questions, and I'm sure Dr. Nalin will answer those questions.
Yeah,
Or you can put it to the chat box if you want.
Yeah, Dr. Nalin, like
Yes.
as you explained, I also observe a situation in Kandy somewhere close to the municipal council library, right? So when the excavation was completed, or when the basement was completed, they wanted to remove the sheet piles, but because of this whole structure, it was not allowed because they observed some cracks during the initial removal of sheet piling. So then they stopped it, right? So finally they had to sacrifice the sheet piles there, right? So how can we decide it at early stage?
I mean, you mean to use them as permanent sheet?
Because it has to be costed.
Yeah. But the thing is, if the installation depth is large, so and the subsurface consists of sandy type soils, this problem can be severe. So because when you take it out, you can't find any cavity or anything, the soil would collapse into the cavity, and the ground subsidence already takes place very fast. But if it is in stiff clay or something, we may have a small cavity and it can be grouted, or it can be filled. Think of doing that. So in my opinion, if the subsurface condition is sandy and the depth is large, better to consider permanent sheet piles.
Yeah, is there any maximum distance for any type of soil, right, that we should avoid?
I have not seen any guidelines regarding this.
Yeah,
it depends on the case.
Yeah, the type of soil and the
Case by case we have to consider.
May I add something on that?
Yes.
I think especially if you have building in the vicinity, I mean adjoining land is also having sandy kind of soil. I think sheet pile may not be the appropriate method unless you do the the silent kind of pile driving.
Yeah.
But even silent kind of pile driving, if you try to take the sheet pile away, you might get problems. Even driving also, there can be a possibility that the sand get densified and sand can settle. And I don't think if you have the building in the vicinity, sheet pile will be the appropriate methodology for shoring. That is my, I don't know. What is Dr. Nalin think about it?
Yeah, I fully agree. Yes.
And also, I want to raise another question to Dr. Nalin. Now, most of the foundation report, I have seen when you have the soft soil at shallow depth, they have recommended to replace with corridor store sand. And for that, you need shoring. I have seen even sometime 4 to 5 meters of replacement of existing soil has been recommended with shoring condition. But as you mentioned, most of time our contractor or even the consultant, they allow the permeable kind of shoring system. I mean, there are no cut-off action. And when you do that, especially you do with shallow foundation, you might end up with a very excessive kind of settlement, because sand boiling or loosening of the sand can take place when there is a upward seepage in the excavation pit.
Yeah.
Unless you devote, if you dewater the pit, actually, that is normally happening in most of the cases. In one way, I think it is also a responsibility of the geotechnical engineer when they recommend this replacement of soil with sandy kind of situation, especially when you have the adjoining buildings. I mean, you have to recommend that cut-off walls are the essential part of the shoring system. I have seen a lot of complaints, also damages in the existing building as well as the new building. New buildings have been settled when you do this kind of construction. Can you add anything, Dr. Udeni, Professor Udeni, and Dr. Nalin on that?
Yeah, I totally agree. So I mean, if you are doing a ground improvement using corridor store sand in a subsurface where the surrounding soil is also very loose sand, then there can be a lot of problems. Sometimes with the groundwater fluctuation, the fine particles in the corridors also can be washed out, and the improvement may not be effective in the long run. So in the carrying out the ground improvement near existing structures, yes, I mean, either using cylinders or some kind of shoring is essential. Otherwise, there can be a lot of issues in and the improvement must extend beyond the footprint of the foundation. Otherwise, I mean, the stress bulb would penetrate into the soft soils, and it can cause a lot of settlement issues.
And also, what
Dr. Nalin, that Mrs. Avandu mentioned another point, that piping can happen if it is loose sandy soil, if you do not consider this in the shoring design.
Yes, it's possible.
That is, actually, that I have seen in most of cases, there is no cut-off action in the shoring system. That is the main problem if you deal the excavation on the groundwater table. And even the geotechnical report doesn't address that point, actually. And because of that, most of designers, they do the foundation design exactly according to the geotechnical reports, but finally end up with disasters like excessive settlement and damaging of adjoining property, buildings, and so on. And I think Dr. Nalin and Udeni, if you can add something on that, especially when we write this geotechnical report, we have to be very careful if you are going to replace the soil especially under the groundwater table.
Yeah, that is true, Mrs. Avandu. Actually, yeah, especially with sandy type of soils with high water table. Yes, we agree that it has to be seriously considered in the foundation design. Yeah,
and also, if you do this kind of excavation, you are bearing capacity. What you have measured during the site investigation process can be reduced due to the piping or sand boiling or whatever you name it, because of the uplift pressure of the water if the groundwater table is lower for the construction of the foundation. That is also a very essential factor we have to consider. Any comment? Udeni?
Yeah, that's why, yeah, we agreed, yes.
Yeah, and I have seen in some cases sometimes corridor dust compaction is done underwater, and some using poker vibrator, and sometimes the poker is inserted. The groundwater level is so high, and poker is inserted. It's very dangerous because it can cause electrocution below the barrel. So above water level is 1 or 2 meters, sometimes above the poker vibrator. So that can sometimes create a lot of health safety hazards.
And also, Dr. Nalin, I want to ask you the question because there are very silence from the audience. The recharging. Recharging also a very tricky business according to my experience. Especially, I mean, it is very difficult to control, and also you can't get the much consistency along the boundary.
Yeah.
It all depends on the methodology what you use. And I think the solution actually for that kind of situation is to have the impermeable kind of shoring system rather than having this especially timber plank kind of thing, where you can get a lot of seepage, and even what you recharge also can wash away the fine particle of the adjoining properties.
Yes.
Yeah, can you add something on that?
Yes. I mean, dewatering, if the water table is high, using timber planks can create a lot of problems. So recharge will not be effective because the fines loss cannot be rectified. No? The loss is once it happens, it happens. So we can only recharge the water, but we can't recharge the sediments. Therefore, I also agree with Mr. Saband. We should not do groundwater charging or using the timber planks, solder pile type retaining walls if the groundwater table is high.
And also, I have seen in many cases the shallow foundation. I mean, the is going to be used after the excavation, especially for basement, where you there is no pile foundation, but only the shallow foundation. But if you don't have the proper cut-off wall kind of shoring system, your bearing capacity will become reduced drastically due to the seepage forces.
Yes.
And I think that is also the area we have to concentrate. But if it is a pile foundation, of course, you may be safe. But even I don't say it's 100% safe, because even during the concreting, you must need rather solid ground to hold the green concrete. But this is also one of a mistake we normally do in our construction.
Yeah.
I think the people who write the soil reports can give more emphasis on these things, because otherwise, I mean, sometimes it is very difficult to change the design, especially architect want to have certain criteria. But then as engineers, we have to take precautions. I mean, especially we have to consider the temporary situation where what will happen during the construction. Any more questions? I mean, I just asked 2 questions. I mean, just to keep the question time move forward. Any more question from the audience? I think the Professor Atul also here, I suppose. So is there.
He was here at the beginning, I think, because of this power cut. I think he might have lost the connection.
Yeah.
I saw somebody from Oman as well initially with his. Yeah, he's still there, right? Any questions from Middle East area?
Yeah, good evening.
Good evening. Good evening.
Yes,
evening.
yes. Actually, I have listened to the presentation. This water table issue actually Oman not coming that much. Sri Lanka is too much. This issue is there, but here almost dry. Groundwater level is very actually around 25 meter, 20 meter like that below. Because of that, those excavations, groundwater is not an issue for the excavations. Anyway, thanks for the presentation.
Thank you, Prashant. Thank you.
Thank you.
Any more questions?
There is a chat. Sir, if possible, please share the recordings of today's and previous lecture.
Previous one I have already shared. Okay, I will share the today's one also.
Yeah, I think I must be very thankful to Dr. Nalin putting a lot of effort and collecting a lot of material for his presentation. Last time also it was a very, very informative kind of presentation, and today also it is the same. I'm very glad that our resource people have put a lot of effort to make a quality presentation for our audience.
Yes.
If we don't have any more questions, I would like to thank everybody who has participated to listen to the this presentation, and also I had to especially thank Dr. Nalin Silla for his effort, and Dr. Udeni Namagama for conducting the presentation. And also I like to remind the audience, our next presentation will be end of April by Professor Samanthi Lakasiri on Eurocode geotechnical design that we normally call EC7. And after that, we may have the course, 1 or 2 days course about geotechnical design according to the Eurocode 7. That is basically the limit state kind of specification of code of practice, different from the earlier approach of service state design. With that brief note, I would like to conclude today's Joy Forum, and also again thank you, Dr. Nalin Silla, for your excellent presentation.
Yeah, thank you, Dr. Nalin. And the next presentation date will be 27th of April. That is the Wednesday, the last Wednesday of April. Right?
Okay.
So, Professor Tilakasiri will conduct that lecture.
Thank you very much for SLGS for giving me this opportunity.
Yes.
Thank you, Nalin.
Okay.
Yeah, thank you, everybody.
Thank you.
Thank you.